we are going to talk about statistical graphs. So our objective is I can graph statistical data. We're going to look at how we do 4 different types of statistical graphs. These aren't all of them, but there's some that we can start with here. So if we look at some data, if we want to do a stem and leaf graph, stem and leaf basically is where you take a digit, list it, and then the second digit becomes the what you add on afterwards. So here, if I look at all these data points, I see that 6, 7, 8, and 9 are the first digits. So I'm going to list those, 6, 7, 8, and 9. Those are the first digits. And to complete the stem and leaf graph then, what I would do then is put the second digit after it. So there'd be an 8 here. Here I'd put a 1, and then a 5, and then a 9. That's the leaf part of it. The stem is the first digit. And then for the 8, I'd have a 3, a 5, and then I'd have another 5 there because it's been repeated. You want to list it twice. And then for 9, you put a 4. This just gives an idea of the frequency of how many times the 60s, the 70s, the 80s, and the 90s show up in this data set. So it kind of gives the magnitude of it by showing the second digits kind of growing to the right with the leaf part of it. Now a dot plot is a pretty simple graph where you just put, like this might have been, for instance, test scores on a quiz. This might be homework scores that we have. And so what we would list is we would just put down below here the different scores that are possible, 0, 1, 2, and 3. And every time one of those shows up, since they're repeated, this is good when you have a repeating on the entire number, you put a dot there. So you put a 0, then a 3, a 2, another 3, then a 1, another 3, then a 2, then another 0, another 3, then another 0. So this just shows, again, it gives the magnitude of how many times that score shows up, but in a very simple graph when you have a lot of repeated scores. So it's a dot plot. A histogram is a very commonly used graph to help show the shape of the data. Now what you have to first do when doing a histogram is you have to decide how big you want the bucket of data to be. You have a choice here. You could make it going by every 2s, or you could go by every 5s. Here I'm going to go by every 10s. So if these scores here, I'm going to group the 50s together. So between 50 and 60, and then between 60 and 70, and then between 70 and 80. Every time you reach a number, you would go ahead and go up to the next bucket of numbers. All right, and I'll put off here, let's see, I'm going to give the numbers here. So I've got 2 in the 50s, so it goes up to 2, and straight across. 60s, I've got 1, 2, 3, 4, so I could go all the way up to 4, which would be up to here. And then between 70 and 80, I've got 1, so it comes down to here. And then from 70 to 80, we have 2 of them, 73 and 78. So we go 2 here. Okay, and that would be our histogram graph. And this kind of shows, this is called a symmetric graph. When you see it kind of going up and then coming back down, that's called a symmetric graph. And later on in other classes, you'll talk about what are called normal distributions, where a lot of graphs go up and then they come back down in data. All right, let's talk about our last one, which is the box and whisker plot. Box and whisker plot, we're going to define some terms here first. The first term I want to define is the median. Median is the middle number. The first quartile is where you look at the middle number and you split the data into the bottom half and the top half. And when you look at the bottom half of numbers, you take the middle number in the bottom half. So middle number of the bottom half. Okay, then after that, we're going to do our third quartile, which you now turn your attention to the top half of numbers, and you take the middle number of the top half. And lastly, the interquartile range is when you look at these two numbers and you take the third quartile and you subtract the first quartile. That gives you a range of numbers. So third quartile, I'm going to say third Q minus first Q. All right, now where these show up on our box and whisker plot, notice that this has a box in the middle of it. Okay, then it's got, these are called whiskers at the end. And what it does is it divides the data into quarters of the data. Here's the bottom quarter of data, the second quarter of data, the third quarter of data, and the top quarter of data. Now, what we label on this is the minimum number, and this one is the maximum number, the largest. Right in the middle, so the middle piece of data is the median. So this right here is our median. All right, now that leaves us with the box part of it. So these two numbers here, where we form the box, the bottom part of the box and the top part of the box, are these two quartiles. So this first one here is the first quartile. We'll put first Q is right there. And then the third quartile, third Q goes right there as that value. So that helps us pick out the data that goes onto this box and whisker plot. That kind of gives you the anatomy of what a box and whisker plot looks like. Let's go ahead and do one. So the first step always is to take your data and arrange it in order. Now our data here has already been arranged in order. Notice it's got this is the minimum point and this is the maximum. If it hasn't been done yet, you have to first of all get those numbers in order. So this has been done for us. So we've got our minimum equals 12. Our maximum is equal to 80. Now we got to figure out where the median is. Now you got to count how many numbers there are and find the middle number. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We got 14 numbers. So there's going to be 7 in the top data set and 7 in the bottom data set. What happens though if there's no middle number, because there's no number right in between those two? Well, when that happens, you average it to find the median. So on this, notice I'm going to count 1, 2, 3, 4, 5, 6, 7. These two are my middle numbers, and you average those two if there isn't a middle number. And if you average those, you get 39.5. That's my median. Okay, so it's important to recognize that point for the median. It's the middle number, but if there is no middle number because there's an even number of data pieces, then you just have to take the two middle numbers and average them. All right, so average if even. Okay, now let's go ahead and find the first quartile and this third quartile. Notice it's the middle number. The first quartile is the middle number of the bottom half. So 1, 2. You don't count the median, which is right between these two. So go 1, 2, 3, 4, 5, 6, 7. I'm going to include the 38 because it's not the median. So there's 7 numbers there. So if I count 4 in from the top or the bottom, I can find the median of the bottom half. So 1, 2, 3, 4. this number right here, this is my first quartile. So first Q is equal to 21. And now we do the same thing up here. There's 7 numbers up here, so the middle number is the 4th. I'll count from the top, 1, 2, 3, 4. This is my third Q, third quartile. So third Q equals 68. Now notice there are 5 numbers here. Sometimes that's called the 5-number summary of this data set. The minimum, the maximum, the median, the first quartile, and the third quartile. Now let's put them on a graph. So I need to represent down here all the numbers. The ranges go from 12 all the way up to 80. So I'm going to just start at 10 and go by 10. So 10, 20, 30, 40, 50, 60, 70, a little bit wider here, out to 80. All right, we're gonna put in, I personally like to, when I draw a box and whisker plot, I like to start with the box part of it. So that goes from the first quartile to the third quartile. So I'm gonna go with first Q is 21, that's right here. I'll put the side of this box right about where 21 would be. The third quartile is 68, so I'm gonna go out here. It's gonna be a big box because there's a lot of data in the middle here. And I form a box around this one. Okay? Then I'm gonna take, and I like to mark the median. The median is 39.5, so it's right about there. You just put a line in here marking where the median is. And then we put the whiskers out to the minimum. Minimum goes down here to 12, right about there. And the maximum goes out to 80, which is right there. Now I've got my box and whisker plot marking all of those important data points. I've labeled it here, so I don't have to label it there. If I haven't labeled it somewhere, I need to make sure I mark down on the graph where those points are. So here we have 4 examples of how we can graph data. Got to make sure that when you do this, you make sure that you follow the kind of the rules for each of the individual ones. And when you do it, make sure that you are clear on your graph. You label important information on the graph so that we can see it, we can analyze it, and use it to inform what information we have about that data set.